This is the Hacker Herald I restored a couple of weeks ago, actually, RP30. I've just got some batteries for it, so I'm starting to use it in the workshop a bit. I've done a bit of recapping on it, but there wasn't a lot needed to be done. I just replaced a few of the electrolytics on the amplifier board. Nothing else really needed replacing. It had the normal problems with shorted transistors and things like that, but it seems to be working fine. What I'm doing this evening is I'm just going to run it through the audio analyzer because I'm just interested to see what sort of performance you get out of the amplifier. Now, these amplifiers are supposed to be quite a good performing amplifier for just basically a transistor radio. Hacker, as you know, are very keen on the quality of their components, and they were very important to them that the sound quality was as verbatim as possible. And hence that's why you'll find on a Hacker amplifier board two adjustments for tuning the amplifier up. You've got the DC offset, or not the DC offset, the DC balance for the two output transistors to make the transistors share and make sure that the amplifier clips symmetrically. Not a vitally important adjustment. If you bought one of these radios and you think it might have been twiddled with, it's not really that critical unless you're driving the amplifier very hard. That will only affect symmetrical clipping close to maximum power. The other one down here on this model is a slider pot, and that adjusts the bias to the transistors, and that is more critical. And that's, I think you bias them. We have to check the manual, but I think it specifies 14 milliamps. So what they ask you to do is they ask you to cut this link here and put an ammeter in series with that and look for 14 milliamps. But I tend to just put usually about 15 or 16 milliamps over the top of the normal consumption of the radio. It's easier. I unplug the connector here, power the radio up, and put an ammeter in series with the batteries and look for my current consumption. You usually find without the power amp board connected, it's about 5 or 6 milliamps. Reconnect that connector and then add another 10, 12 milliamps, something like that, and that will give you a sort of a good battery life and reasonably low distortion. Now, as I say, this one's been recapped, and I think I changed possibly a couple of resistors. I can't see them at the moment. What I'm going to do is I wired it up to the audio analyzer, and first of all I'm going to just do a frequency response test. Now, bear in mind this has got adjustment tone controls on it, so you probably won't get a particularly good response out of it, but it'd be interesting to see if you can actually get it anywhere near flat. I'm going to start the frequency at 100 Hertz because I don't think there's any point going any lower than that really on a radio like this, and a stop frequency of, I'm going to go 15 kilohertz because that's out of the audio range of a large drive unit like this anyway. So what we'll do is we'll start the sweep by, we'll go to our center frequency of 1 kilohertz, which is our reference point, and we check our 0 dB reference. I'm going to just either do that by pressing the ratio button again. So we've got 0, and then we start the sweep and just see what our response is like. So it's going to sweep from 100 Hertz to 15 kilohertz. So let's start the sweep. Okay, and you can see a bit of bass boost there, probably deliberately put in by Hacker to get the bass response out of the cabinet. And you see the top end response, pretty good, 2.5 dB down at 15 kilohertz, and that is actually why these radios often sound quite warm sounding. Let's try that again with the treble control turned up a little bit. So the treble control's now at 12 o'clock. Let's take it around about 2 o'clock, and then we'll sweep again and see if we get a better response on the top end. So as our low end boost, and it's affecting more the mid-range and the treble really. Doesn't make an awful lot of difference. So what we'll try is frequency. Let's go 10 kilohertz and adjust the treble control so we can get that down a bit. Wrong way. Of course I've turned it the wrong way, haven't I? Because I'm looking to it backwards. Okay, let's do it again. So let's set that to about there. The pot's a little bit noisy, I must admit. And we'll sweep again. Hopefully that's about 1 kilohertz, it should flatten off. Pretty good. So it's got a bit of treble boost, and that's probably again deliberate to get the treble response out of the speaker. So let's try and see if we can actually make the amplifier anywhere near flat. It's a pretty pointless exercise, but it is interesting to see how good these amplifiers are. So let's go frequency 100 hertz. Let's turn the bass down. Okay. So the bass control is actually, as you see, almost all the way down. Start frequency, stop frequency, so let's sweep again. Okay, we got it. Still got a little bit of a top end boost, but as you see, that's within 1 dB. So for reference, if you want a flat response from the amplifier, the tone controls need to be about this position. So it's about 7 o'clock on the bass control, and about more or less flat straight up on the treble. Actually, seems to be giving a good response now. Once you turn the bass down, it seems to have pulled everything into line. So it's probably just the bass boost it's actually giving, and that's why the treble was looking like it was peaked, because the bass was all out of balance. Okay, so that's that. Now let's check the distortion. So we'll do frequency 1 kilohertz and check our distortion. And you can see there it's 1.4%. Really, for a transistor radio like that, is pretty good. Now what you can find is if you turn the amplitude down, so we're 100, what's our amplitude at the moment? 50 millivolts. So I'll go down to 25 millivolts. This is looking for crossover distortion. And what I'm going to do is I'm going to increase the bias on the biasing resistor. So we're at 1.8% distortion now. Push this pot over and increase the bias slightly. That's 1.6. I'll do it I'll slide it along as you watch. I'm increasing the bias. I can hear that improving. I can really hear the sound improving actually. 0.9. That's as far as it would go. I'll get it down to 0.9%, and I can hear now. I don't know if you can hear the distortion. Let's bring it back and have a listen. I don't know how good the microphones are on the phone, but let's have a listen. Bring it back. Can you hear that? That's worse. That's severe distortion. Reducing it. 1.6%. 0.9, 0.8, 0.7. Whoop. Something out there, have to be a bit careful. I'm trying to watch the meter, I think I shorted the transistor out. 0.9, 0.8, 0.7. Can get it down to about 0.8%. I don't want to go too far though, because you're starting to increase the bias too far. So I think if we can get it down to 0.9%, I'm quite happy with that. 0.91%. So that's improved the distortion on the amplifier as well. So yeah, I don't know if that was of interest. I hope it was. But that's the just goes to show how good these Hacker amplifiers really are. And thanks for watching.